Good morning, ladies and gentlemen. I am Jean-Claude Charpignon. I'm from France. I am probably one of the 2 or 3 ornamental turners you can see in France. I probably moved to Rosc engine work after 2006-07 when I met an old French wood turner who was ivory turner. He was occupied during 30 years in repairing old stuff, ivory works from the 17th, 18th century. So when I've seen the work he did, he did ivory work inspired from the Coburg Ivory. So when I've seen this, my first project was to visit the Florence Museum to see the Coburg Ivory. But come back to my presentation. So this presentation shows all the equipment I have built from 2004 until now to make me able to produce ornamental turning and Rosc engine work. The first part will be about the ornamental lathe built from the first mid-size lathe I have bought in the early 1980s. It's a light-duty lathe with a center height of 8 inches, which makes possible to work rather big pieces. I discovered later the limit of this machine as it was built with mostly aluminum alloy. The lack of rigidity was the main problem, which pushed me to build my first real Rosc engine in 2009. So this is my ornamental lathe. It was a kitty French lathe made of aluminum, and the base, the foot are made of metal shield, and the bed is made of aluminum profiles. So I repeat, the center height is 8 inches. I can, with this ornamental lathe, make spiraling. I have a ball screw with a pitch of 5 millimeters. The carriage with 4 linear ball bearing moving on the 2 inches hard steel rods. 2 1 inches hard steel rods, it's not 2 inches. The cross carriage has 4 linear balls bearings moving on 2 1 inches hard steel rods. I have on this carriage a Chauvelin cross slide. The second shaft, I have a second shaft behind the lathe, which carry 1 rosette, moving the tool as spindle fixed. Something is not clear here. This could be used for thin piece with the help of the tailstock, because I have no rocking movement. The second shaft and the spindle are gear connected. The ratio could be different from 1 to 1 to multiply the shape from 1 rosette. This lathe is not very rigid. It's not suitable to work with fixed tools. If you have any question, you can ask me. I will try to answer. This is the side view of the ornamental lathe. A gearbox with a 3-phase motor controlled by an inverter drives the second shaft. The second shaft is connected to the spindle by a gear train ratio 1 to 1, and the lead screw could be connected to the spindle by a group of gears to give the required pitch. The pitch range of this machine is between 5 to 400 millimeters, which allow to make a very long spiral pitch. Here it's an example of kind of things we can do with this versatile machine. This setting shows a chain connected to the lead screw. The second shaft has been made to make a kind of straight line work using a rosette to move the tool. The tool, in this case, a drilling bit on an engraving bit in cross direction when the carriage is moving in the length direction with the lead screw. Do you have any question? No, I continue. This view shows the lathe set to produce tapered work. The square piece of steel is clamped on two arms attached to the lathe bed. The rolling rubber connected to the cross-direction carriage will follow the taper. When a pattern is clamped on this beam, we can make curvilinear work. The cross slide I use, at the beginning I have been using a very old cross slide coming from a French lathe. It was a bit worn out, and then I have bought a second-hand Chaublin cross slide, which is a very good, probably equal to the American Hardinge you use, yes. It's generally used on a 102 Chaublin lathe. We can sometimes find this kind of cross slide for about $500 US, but it's not very often. It's a very high quality level cross slide which works with an accuracy, a precision of 100th of a millimeter, which is more than enough for woodworking. The cross slide is set on a linear bearing guided carriage which can be connected either to the rubber in contact with the rosette or with another rubber used on the curvilinear work. This Chaublin cross slide has a tilting table which could be used in some special situation to set the cutting tool at the right angle or place. The tool holder. The tool holder I use is a very basic and cheap Chinese model, which is generally used for very small metal lathe with a center height of 5 inches. It's far from the quality of a Chaublin cross slide, but it's good enough to work with wood. I've seen that generally you use a stronger tool holder here, better than the one I use. The universal cutting frame, mostly made of aluminum, except high-speed steel homemade cutters. The thickness of the cutters is 3 mm and the maximum width is 10 mm. The center height is adjusted with a tool holder and the angle is adjusted by tilting the head. The aluminum block under the head is used to set the cutting frame on a Rosc engine. The screw on the top of the head is used to set a sewing machine motor where the overhead drive is not available. I have an overhead drive only on my ornamental lathe, but when I use this cutting frame on my Rosc engine, where I have not any overhead, I use a sewing machine motor, which is something very cheap with high speed and easy to work with and easy to adapt. This is the overhead drive I have on my ornamental lathe. It's just 7 millimeter diameter. The motor, you can use a motor with a standard speed adjustment with a treadle, or you can use a kind of tension variator to change the speed of the motor. In this case, you can probably see the tool I use. It's an 8 millimeter rod in which I've drilled a 3 millimeter hole to carry 3 millimeter tools I made from generally high-speed steel or old drilling bits or old milling bits. And this could be used as a very small radius cutting frame, probably a radius which is about ½ inch. This is a detail of the pulley I've used to drive my drilling chuck. It's simply a pulley made of boxwood. And when the pulley on the motor is made of plastic, white plastic, and I have two directions of running by crossing the belt. This is another example of drilling chuck, which is a bit bigger. It's here 16 drilling chuck, which could reach a diameter of, if I remember well, 10 millimeter, yes. And same system, I use the same frame with a 43 millimeter collet. Here it's my dome chuck. This dome chuck is fitting on the spindle by a M33 connection. It is a standard in Europe. And it is a standard I have used on all my lathes, plain lathe and also ornamental lathe. I use a dividing plate with two rows, one with 60 division, one with 48 division, and I can adjust the eighth of cutting to do that. Here is my eccentric chuck, which is made of aluminum and steel and plastic. The connections I use for the dome chuck and for the eccentric chuck for the piece is M16. It's something easy to work. I can tap boxwood with engineering tap without any problem. So this is what I use. This eccentric chuck could have an eccentricity of 20 millimeter, and the dividing plate inside has a 60-old division. So the travel of the eccentricity is made by a screw with a pitch of 1 millimeter. So I can adjust with good accuracy the eccentricity. This is the index and dividing plate. So on the lathe, as a plate, I have used a big gear collected on an old machine, and I have drilled several rows of holes. The one with 144, the second with 120, then 96, then 42, and 24 holes. The index is simply made with too thin steel bars, which are flexible enough, and a screw is used to go in the 3 millimeter holes of the dividing plate. Here it's the eccentric cutting frame I have made. It's a big plastic pulley, which can receive some balancing weight. And the part which hold the tool has a capacity of 10 millimeter width for the tool, and I have a 3 millimeter threaded rod with a pitch of 0.5 to adjust the radius of the eccentric cutting frame. Here it's another view of the cutting frame, which show the pulley, the balancing weight, and the travel of the tool. This is a view of the milling attachment you have seen before with the router motor. So the interest of this is I can work, it's like a big universal cutting frame, in fact, on which I can move, I can change the angle, I can move the center eight if necessary. This is now how I work with this ornamental lathe at the Rosc engine. I have a second shaft behind the lathe. You can see the shaft carrying the rosette. And I did that in 2007 to make my first Rosc engine, in fact. I had, at the beginning, I've used some plastic rosette made of perspex and cut with a laser cut. The quality was good enough to work with a big diameter rubber. So I've used the second shaft, which is I don't know the name in English. It's not square. It's a shaft which is used on transmission for tractors, tools. Yeah. Okay. So I have the connection. The cross, the cross direction carriage is connected to the rosette by a threaded rod, and I can adjust the amplitude by moving the link. The link, you see the link which is connected to the rubber with a yellow button. I can move up and down to adjust the amplitude of the travel. So it's something you can see on all the birch machine. And so here it's a detail showing how the amplitude adjustment is done. So the rubber is in contact with a lever on the rosette, and I can move from the fulcrum to the bottom. Into the fulcrum I have the minimum amplitude, and to the rubber I have the maximum amplitude. And to have horizontal position of the link, I can move the link from up to down by several holes, threaded holes. And with this device, I can adjust the amplitude from 20 to 100%, and it's rather accurate.
You change that yellow button on the rosette to different sizes?
Hmm?
The yellow rubber?
Yes.
You change that?
No, the yellow rubber, it's not the rubber, it's just a button to tighten the position. The rubber is the piece of clear aluminium you have sharpened here. Ah, you have? Okay. Thank you. This one is the rubber.
Yeah, I see that now. Yeah.
So another interesting thing I can show you is this rubber could be set behind the rosette to have the symmetrical shapes. I have just, in this case, I have to change the link by a longer link. So this is we have seen all the function of the ornamental lace, which was used from 2007 to 2009, also as a Rosc engine with flying cutters or drilling cutters. I have never tried to work with fixed tools with this machine because it's not rigid enough. And in 2009, after having seen the limit of the Rosc engine I have made with my first kitty lathe, I decided to make something stronger and more rigid. And for that, I have bought an old, very old Charpignon lathe. First, because I was interested by the cross slide, which was a long travel cross slide, 6 inches, and the price was very low. I paid this lathe and cross slide 450 euros in 2009. And when this lathe was in my workshop, I started to work to make it from this lathe a Rosc engine. So on the top of the picture, it's the first design I've made in 2009 with a rosette made of perspex, and the rubber was clamped on a steel box with screws. There was not at this time any automatic feed. It was the first prototype, I can say, I've used during a few months before changing some tricks on it. No, second part, behind you see the actual design of the machine. The rosettes are now made of steel, including the pumping rosette, which is here, which is made from a steel pipe. The steel rosettes are here. They are generally got from laser cut in 6mm steel plates. The rubber is clamped with a big knob here. And I have beside an automatic feed. This is the cross slide I use now on this machine, and you have the clamping box for tools. The tools I use now are 3mm thickness high-speed steel, generally cut from planer blades. In the beginning, I've started different things. I've started to work with very thick high-speed steel, but it was really difficult to cut the tools and long because I had many particles of metal to take off. I have tried also from steel, cutted by standard tool like files, a milling machine, and so on. And then hardening using my furnace, but it was also long, and I have seen some trouble in to have the right hardness. So finally, I decided to work only with a 3mm high-speed steel plate. I buy planer blades with a width of 35mm, and with 35mm I can generally make all kind of tool I need. And Obviously, I cannot use any file or milling machine to cut, so I all shape my tool by grinding. The first grinding, I use angle grinder, a 5 inches angle grinder with a very small disc. Generally, the thickness of the disc I use is 1 millimeter or sometimes less, 0.8 millimeter, to make details. And I finish using other grinder that we will see at the end of the presentation. On this, you can see the rocking frame, which is made of aluminum plates and contains bronze bearing. The bronze bearing here is split, and the aluminum plate is also split, so with a screw which is here, I can adjust the play to have no play between the spindle and the bearing. And on the top, I have used some plastic container to put oil and to give oil on the spindle. It's enough. After some years of work, I've not seen any worn out. So I have a spindle which is a 30 millimeter diameter steel, hard steel for the second Rosc engine, semi-hard steel for this one. The nose of the spindle is M33 because all my machines are M33 with a pitch of 3.5 millimeter. So I can work on my plain lathe to make rough cutting. Then I move the chuck and the piece to another lathe, and I can work and change easily. The rosettes I use are now made of steel, 6 millimeter steel thickness, and the rubber, you can see the rubber here, is a 6 millimeter piece of high-speed steel or carbide coming from broken milling bits, running on 2 bearings on a kind of fork you have here. And the rubber is clamped by the system and the screw you have here, the knob you have here. So you have to, you can imagine that when we work with fixed tool, we have a higher strength than working with flying cutters. So we should have high pressure, and this pressure is a direct function of the width of the cutter. So behind here, I have springs, you see, and I have one spring on each plate of the rocking frame. Then you can see also here the connection with a 3 millimeter round belt to a shaft which is in front of the lathe. It's a square shaft on which I can move pulley to drive different automatic feed. Here, this is a pulley which drives the automatic feed, which is here, given by a 8 millimeter screw. And we release, when we start, we have pushed the spindle out of the cutter, and slowly, by turning with the automatic feed, we bring the piece on the tools. On this view, I show how I can phase the rosette. I have two perspex discs with 121 with 120 rows and one with a pin. By moving, by turning the spindle, the rosette barrel by the number of, by the required number of hole, I can phase the piece. It's a bit rough, but it's working. You see this system is a system which clamp the disc or the barrel on the spindle. The spindle is it's a very simple spindle. It's just a piece of a cylinder of steel, except the connection with the threaded end of the spindle. This is an automatic feed which has been made after the construction of the machine. I use a 3mm green belt, same here. Here is the square shaft I have in front of the lathe, the Rosc engine. The driving is made from the spindle to the square shaft, and I have here a moving pulley which drive the gearbox. This gearbox is made with worm and wheel, homemade worm and wheel. I use a M14 millimeter threaded rod as a wheel, as a worm, and the wheel is cut with a tap on my milling machine. And it's very easy and quick to do, except when you want an exact number of teeth. Using directly the tap in the worm, you could have a difference of 1 tooth. But if you use a dividing table to prepare the cut, you have the exact number of teeth. Is it clear until now? Do you have questions? It's not boring. Let me know if you have any bad feeling.
Good.
It's good? Okay, thank you.
About how much pressure do you have on the screws, the springs, to force the work?
The spring to force the work, you will see on the next slide.
About how much force?
Above. In fact, I've used the spring coming from the valve of motorbike motor, and I've used a series of maybe 3 or 4 in a pipe, and I have an adjustment of the strength by using a screw. So what kind of force is probably something like maximum could be 25 kilos, I think. So this is the automatic feed in cross direction, but also in left direction. And you can see the construction of the automatic feed. You have here the threaded rod, which is M14 millimeter standard threaded rod, a bit rough, but good enough. Two ball bearings here and here, 6 millimeter ball bearings, a pulley made of steel and perspex. Here the worm. The worm is made of brass here. And the worm is turning on a shaft with also two ball bearings, and the worm has been cut with a tap, with a M14 tap. It takes probably 3 minutes to make a worm, and it's good enough for this kind of thing. And I use this equipment not every day, but very often. It turns 8 hours a day, and I've been built this maybe 5 years ago, and it's still okay. This is another view showing the two posts with the springs. The springs are here. So in the pipe here, I have several springs in order to have a constant strength. When you want to have a constant strength, you should not use a very short spring, but a long one. This is what I do. And we don't see here the end of the pipe, but at the end of the pipe, I have a screw which is able to push the spring to adjust the strength. In fact, I have to adjust the strength and to increase the strength when I use bigger cutters. So here you can see where? Here. The end of the pipe with a screw. So here it's the rear, the flying wheel, which is driven by a half-inch V-belt. Beside, you have a plate. This plate is a swash plate, which could be angled to make swash work. And the spring here is to keep the spindle in the rear position. Oh, sorry. Here it's a side view of the machine. You can see the yellow frame of the old Chaublin engine, and I have intermediate shaft on the side of the frame. I have first the long driving V-belt is here. Here, the intermediate place, I have a motor here on the side, which is a worm and wheel gearbox with a three-phase motor. It's a 250 watts three-phase motor driven by an inverter. And the first stage is I can change the belt also, but generally I don't use this second pulley. Here I show the work of hexagonal box. So to work with an hexagonal box and to have flat faces, it depends on the rosette diameter and the piece diameter. So if you have not any amplitude adjuster, you could have trouble if you want to make a box with a different size, different diameter of the rosette. So here, to finally get the flat side of the box, I use my amplitude adjuster, which is a personal construction system, a bit special. I've spent a few hours to find a way to do it, because my problem at the beginning, I was using for the same shape two kinds of rosette. One rosette with a certain amplitude for big diameters, and the same number of bumps, for example, with smaller amplitude to work on small diameter. And because you cannot use a very high amplitude when you make a small diameter. When you want to make the body of a piece, you should use a rather big amplitude, but when you want to make the stem with the same shape, you cannot use the same amplitude. So it's necessary to have either two kinds of rosettes or to use an amplitude adjuster. I suppose some of you are already using this kind of equipment. So the amplitude adjuster I've made is able to work between 20% to 100% of the resonant amplitude using my standard roller rubber, which is a 6 millimeter diameter. This means that when I have a piece of 100 millimeter diameter with a maximum, I use the maximum amplitude. But when I use the stem, which is 15 millimeter, I use generally the minimum amplitude of 20% to have the same ratio of amplitude on the piece. And now I think I could not work without this equipment. And I have also made another one for the pumping. For the pumping in pumping direction, I've made another amplitude adjuster, which is not with continuous adjustment, which is using a link. So I can move this link from. I have different position: 1, 2, 3, 4. Yes, five different. 1, 2, 3, 4, 5. Yes. Yes, 5 different positions, each corresponding to a step of amplitude adjustment. So I have a follower here, which follow a rosette, and I have here the rubber. The rubber is a 6 millimeter rod rolling on 2 ball bearings, which is in contact with the pumping rosette here. So instead of having a continuous adjustment as I have on working direction, I have a step-by-step, which is more than enough. And it is easier to build. So I have in this all the fulcrum as ball bearings. I have a standard ball bearing with an inside diameter of 6 millimeter, outside 15, and the width of the bearing is 5 millimeter. I buy this kind of bearings by 100. So this picture is showing the hexagonal box working with a fixed tool, and here I am doing the hollowing of the box. So I have a hollowing bar, in fact. In this hollowing bar, at the end, I clamp a piece of 3 millimeter high-speed steel cutter with the angle is close to 90 degrees at the end to finish the bottom as perfectly as possible. And I use the automatic feed all along the hollowing, except at the end I finish slowly using the cross slide to finish as perfectly as possible on the bottom. First, I don't use hand tools to do that. I use the first hollowing is made on a lathe with a cross slide to have better accuracy in cutting and in finishing. So what we have seen is until now was the first Rosc engine built in 2009. And now we will see the second Rosc engine. Why this second Rosc engine? The idea was to have something which could be transported to show Rosc engine work with fixed tool in some exhibition or symposium. So the first travel of this was in 2015 in Loughborough in the UK for the AWGB symposium, and this was on the SOT stand. during all the meeting, working continuously, automatically, most of time, because I had to make some presentation beside. And it's something with a weight of 80 kilos, which could be dismantled in 3 big parts. One big part is the cross slide, which is a very heavy cross slide, this one, coming from a kind of lathe which was used to adjust cams on automatic metal lathe. The weight of this is probably 20 or 25 kilos. Then beside, I dismantle all the rocking frame. I also dismantle the motor. And the frame, the bed of the machine is coming from a small bench lathe, metal bench lathe. I use also the same kind of inverter, which is a Siemens inverter. Here.
It's 176 pounds.
80 kilos? It's 160, no?
176 pounds.
Okay, okay. So to build this project, I started from the heavy cross slide I've bought as second hand. I think I've paid this cross slide 200 with the machine beside. And finally, I think the total I've spent to make this second Rosc engine was roughly 1,000 euros. So here is the engine, the motor, the gearbox, motor, gearbox, and the driving. I've made something very simple, and the frame of the motor gearbox is sliding with a square pipe on another square pipe, and this also gives the tension of the belt. The gearbox, it's a Chinese gearbox. I've paid 50 euros, delivered in my home. It's good, but there is a small play in the gears, which could bring some troubles when we work. This is the tension adjustment with a square pipe sliding on another square pipe, and just above here, you can see it's a fulcrum of the rocking frame. It's just a simple, standard piece of mechanical, which is automatically in line without hard point. The motor is 120 watts, 3-phase, 4 poles, and the gear ratio of the gearbox is 1:50. The aluminum flywheel is probably the sister of the aluminum flywheel of the other Rosc engine, and it was coming from an old washing machine. Sorry. So you can imagine that all this equipment was free for me. Yeah, sorry. This is the first step of connection between the motor and the gearbox. It's made of boxwood pulleys set on a steel center with two levels to be able to change the speed. And the belt is a round belt which with a diameter of 6 millimeters. And it turns very long time without any trouble of breaking the connection. Now it's a Siemens MicroMaster inverter. It's something I've bought as a second hand on eBay long time ago, probably for, I think, 30 euros, yes. It's able to drive a motor of 0.37 kilowatt. And the big interest of this kind of inverter is you don't need any special button box beside to drive the motor, because you have everything on the front panel. You just have to connect the power on and the motor. All protection of the motor are set in the inverter, so it's probably the best way to do something very simple. Here is the spring here. The spring here is a bit smaller than the spring of the other Rosc engine. With this machine, I cannot work with very large cutters. So I've used very simple spring, and this spring is coming from a farming machine. It's to work hay. And it's a kind of lever with a spring here. You see? And it's good enough to work with tools with a width of, I can say, ½ inch. Here is the pulley which drives the automatic feed. And behind you have detail of the pivot we have seen before. It's only that. It's male pivots with a thread inside the plate. So you can see here the detail of the plate, which is split here. Split here, we have a screw here to tighten the connecting bar. This is a connecting bar between the two plates, because obviously I did not make any cast iron piece, because I have not any foundry in my home. And behind you see the spring. To adjust the tension of the spring, I turn this piece with a wrench here, the wrench here. This is the view of the automatic feed, which is the same as the one we have on the first Rosc engine. You see here the screw, the end screw, the spring which is here to avoid the unwinding of the screw with vibrations. And here you see the screwdriver. The screwdriver, it is a pipe split in two to be connected to the screw. Another view of the screwdriver here. The spring, which keep the spindle in rear position. Here inside the boxwood plate, I have a ball bearing, which makes the spring free to avoid turning. On this Rosc engine, I've improved the phasing device by using a worm-on-wheel system. I have this first place clamped on the spindle. The part containing the screw is tightened on the spindle, and the part with the worm wheel is attached to the barrel, to the rosette barrel. And the rosette barrel is clamped on the spindle by this screw. I have a 90 teeth worm. That means I have, for one turn of the screw, I have 4 degrees. So it's easy to have an accuracy of 1 degree, which is enough to do phasing on wood. Maybe it's not enough on metal, but I have no experience in metal. This view is showing the amplitude adjuster with the piece of meter here to show the position. Here I've not set any screw to adjust the position of the fulcrum. It's just a piece of plastic which keep the fulcrum at the right position with a clamping device here. So I can, on this amplitude adjuster, move the fulcrum from here to here in order to change amplitude from 20% to 100% of the rosette amplitude. These screws can tighten the automatic feed on the bar here. I have a bar on which I can move the device until reaching the screw driving here and clamping by these levers. This is the cross slide, and the cross slide could be moved all along the bed and clamped by this screw. And this is the automatic feed in length direction. I've not made an extra shaft in front of the lathe because when I travel, I don't want to have something too fragile and too risky. So I have made an automatic feed here, set with a magnetic foot. And this is a motor with planetary gearboxes. It's planetary gearboxes I've got in the SOT auction for a few pounds. And I use a 30 volts direct current motor supplied by a phone electric supply, though with a very low voltage, so I have a very low output here. I don't know exactly the gearbox ratio, but it's probably something around 1 to 500 or something like that. And the motor speed is reduced because instead of 30 volts supply, I use 5 volts. I can reverse the speed, the direction of turning by changing the connection as it is DC current. So this is the cabinet I've made under the table of this Rosc engine, and I have it's something I've got. It was used to connect to organize some paper sheets in a library. So it's long drawers. And in these long drawers, I have put all my tools for Rosc engine work and sometimes for screws and so on. This is another machine because we have finished with the Rosc engine and ornamental lathe. And beside, I have separate equipment. This one, for example, is used to make thread. I have a router here with a cutting tool with 60 degrees angle. Here I have an old cross slide. It's the first cross slide I got for my equipment. It's something which is not as accurate as the Choblin, but it's good enough to make threads. I have here a spindle with always a M33 times 3.5 thread, and at the end of the spindle, I can change the mother lead screw thread. I have different thread with a pitch of 3.5 because when I want to make a special chuck, I can, for my lathe, I can use my threading machine. I can also use 3, 2.5, 2, 1.5, 1, even 0.5 millimeter when I want to make, for example, a thread for pens or 0.5 could be used. This kind of equipment allow to make thread in any wood. And it's very accurate because I have here on the cross slide the same capacity of accuracy that the one I have on Chaublin, except it's a bit worn out. This is another view of the threading machine. And you can see here I have a special coupler to make smooth movement and to avoid hard points. It's the construction is a bit rough, but this is the last evolution of the threading machine. And from time to time I change because I have to improve either accuracy or something else.
How do you index to get a triple?
Because I have the second slide in this direction. If you want to make a double entry thread, you move here by half of the pitch, simple, or by a third if you want a third free entry thread. Here it's a view of the box containing my fixed tools. I have probably now 100, and each time I start a new piece, I have to make new tools. So it's you can see the tools. It's different kind of shapes: male, female, concave, convex, straight. Here you have the hollowing bar, where you see here the small grain, which is used to have a good connection between the side and the bottom. Here it's a detail about my tool holders. On the right side, you can see the standard tool holder, which it's a block of, in fact, it is 2 inches times 2 inches times 2 inches. And I clamp the 3mm tools in order to have the minimum outboard of the tools to avoid or to limit vibrations. And on the left side, I have another of tool holder, which is a tool holder where I can give an angle to the tool to make angle cutter. Here it's the kind of grinder I use to give the bevel of my shaped tools. I work here with it's a 6mm grinding wheel width. The diameter is 150, or was 150 at the beginning. I shape the tool with a diamond to make it round here. And I have a plate with an angle giving the bevel angle, and I generally work with 20 degrees bevel angle, or 20, 22, it depends of the diameter of the wheel. On the other side, it's also possible to make a rough cutter because it's a coarse wheel. Here it's another grinding equipment I have made. It's the vise. It's a vise you can turn at any angle in 3 directions. The wheel, it's a diamond wheel. I use diamond wheel to sharpen high-speed steel because it's possible, and the wheel costs nothing. It's something coming from China. I pay each wheel 12 euro. It's a 100 millimeter wheel, diamond. I have different grades from, I think, from 120 to 1500. So it's good enough, even for high-speed steel. And the vise is set on a sliding carriage, which is set on a cross slide. The cross slide is also a Chinese cross slide, which is good enough to make some sharpening. But most of time, I don't use this machine. I use my hands. I draw. I make the drawing on the tool itself, and then I cut. And I check on the drawing of the piece to have exactly the same shape, because I always start when I make a new piece to make a drawing to have the detail of shapes, and I make each tool to fit on the shapes of my drawing. So we are now probably we are in time, no?
You have a couple minutes.
Oh, good, fantastic, because it's finished. No.
Any questions?
No, if you have questions, it's time to do it. But all this presentation, I've given the files to Charles and David, and they can do what they want with the file, sell to you or given to you. It's depend of the treasurer. So, do you have questions? Thank you.
Fred has a question back here.
What RPM do you generally find is amenable to this work?
With fixed tools, the RPM is between 1 and 10 rods per minute, depends on the diameter.
The other question is, what kind of included angle on the cutters?
20 degrees bevels. 20, and I finish after grinding, I finish with leather polish, leather and past, to try to have a mirror polish. If you do less than 20 degrees, you have quickly cracks on the cutting edge. I know Jeremy Soulsby is using sometimes 15. I've tried 15, but trying 15, I have had very often cracks very quickly. So I decided to increase the bevel angle to 20, even 22, 25. It depends on the shape, in fact. It depends on the depth of cut of the bumps. If you have a very deep bump, you should go with very small angle bevel. So this is also the interest of having an amplitude adjuster. You can reduce the amplitude when you see your angle is a bit too big.
Thank you.
You are welcome.
Josh has a question here.
What thread pitch are you cutting for threads? What's the pitch?
What? I have not understood your...
16 or 20 or what's the pitch?
What's
the
your
pitch
thread
of...
pitch?
The
Your thread pitch.
thread pitch, in fact, it is for me. It's easier in millimeter. I use 3.5 millimeter, which is 1.5 inch or 1.25 for my spindle thread. I also use 2 millimeter. 2 millimeter is not a tenth. A tenth is 2.5.
80,000.
Yeah.
What does that translate to for thread length on the work?
It depends to make boxes. Boxes I use 2 or 1.5 millimeter. 2 it's. But sometimes on big boxes you can use 3.5. It depends on the size of the box, but not too small, because if you use a very small pitch, you have if the wood is not perfectly dried, you could have troubles. I don't hear, sorry.
Everybody should be in metric anyway.
No, I only work in metric, yes.
Jean-Claude,
Yes.
you said you let these machines go, when you're doing your fixed work, you set it up and you're going 8 hours.
Oh yes, I have sometimes some cuts. I should leave the machine during more than 8 hours, yes.
So you go to sleep and
Not to sleep, no. No.
wake up in the morning and...
Generally, when the machine is running with automatic feed, I come sometimes to have a look on the machine. And generally, I am beside to do something else. As you know, I have several machines, so I can work on other machines. Yeah.
And you can hear,
Yes, I must be beside, because the sound sometimes show problems.
What's the feed rate of your retractor per rev?
The feed,
Your headstock retractor, the headstock going into the rubber.
I always try to have a cut of hundredth of millimeter per turn, which is very low. Hundredth of millimeter, which is yeah.
4/10 actually.
Yeah, 4.
David has a,
Jean-Claude, in England there's a couple of hundred that's interested in OT and engine turning. In France, as far as I'm aware, there's only yourself and Paul. Is there any sign?
Yes, there is some other guys, yes. I know 2 of them. One is probably the best I have ever seen. He is rather old. He has been working with ivory during 35 years now. And he was working for a collector, an antique dealer, to repair old pieces from the 17th century. And I've been visiting him with Paul in 2006. And when I've seen what he did, it was, in my mind, I was thinking that it was something I should do in future.
Given what you're doing, do you think there's more, you should be stimulating other people coming in, seeing what you're doing?
It's difficult because you know, in France or everywhere, if you want to buy an old machine, it costs a lot, except if you buy one of the Linda White. You know, you have sold one in France.
I did. I don't
We-
know if he ever got it together.
He is trying to start the machine. He is Jean-Renaud Scordia.
Yeah,
And I'm in contact with him.
good.
He asked me a question about how to do things, and I give him some tricks. So we have now another one, and beside there is also another man existing near Lyon, who has made his own machine. He's working with drilling cutter and flying cutters, and he makes pieces a lot.
Thank you.
So not so many wood turners in France, and no collectors. No collectors of machine, you know. So sorry. Thank you.